Hello everyone, welcome to RASAAYANA Institute of Sciences. In this video, we are going to start with a new chapter, IUPAC nomenclature. So IUPAC nomenclature, generally it will explain the name of the organic compound. So what are the possibilities of giving name of an organic compound and how to follow some selective rules to describe the complete name of a organic molecule. Everything we will discuss in this chapter. Okay, let's start. So generally, if you want to give any organic molecule name, see, organic molecule name expressed in two ways. So two ways we need to express a name of an organic molecule. So if you want to give any name of an organic molecule, we need to express in two ways. So first one is common name, second one is IUPAC name. Two names we can apply, common names, second one IUPAC name. So what is common name and what is IUPAC name? Everything we are going to discuss separately. So actually, if you want to know about what is common name of a organic molecules, remember, generally common names are completely derived from previous history. Otherwise you can say source name. It is belongs to a source name for any organic molecule. Source name, otherwise it is also called a derived name. Derived name. It is also called trivial name. Trivial name, tentative name. Okay. So it is also completely related to history of a molecule. History of a molecule. Name derived based on the history of a molecule. So from where it is derived, that derived source name will be included on common. Okay, and what is the history of that molecule and from where it is extracted, that all are called trivials as well as derived names of a given molecule. Okay, so common name is not a systematic name. It is not a systematic name. It is impossible to write common name for each and every organic molecule. Okay, so common name may be repeat for more than one molecule because one molecule may be source for multiple combinations. Suppose 10 molecules are there, 10 organic molecules extracted from one source. So if you are extracting 10 molecules from one source, that one source name will be given to this 10 molecules. So that's why it is not a systematic name, may be repeated. So they are limited in number. Okay, limited in number. So that's why we can't give common name for each and every organic molecule. That point you remember. Okay, so suppose few examples I will give related to this. This is one example. Generally it is known as methanoic acid. So generally what is the common name for this one? This is called formic acid. This is common names. It is a molecule and this is a common name of a given molecule. So formic acid, generally known as methanoic acid, it is a common name, but it is not a IUPAC name. Why we are giving as formic acid name? One special story will be there. So generally formicus, nothing but a red ants. In strings of red ants, there is a branch of a one common acid. That acid is called formic acid. That's why that name given as formic acid. So source will be red ants. It is most commonly available in red ants. That's why the name given as formicus. Formicus nothing but red ants. The acid present in red ants is formic acid. Next. So you may take few more examples. This is CH3 C double bond OH. Generally it is called ethanoic acid. Common name is what? Acetic acid. I am saying it is acetic acid. Acetic acid generally belongs to acetum, sour taste. It is belongs to sour in taste. So the presence of sour taste belongs to acetic acid. That's why the name given as acetic acid. So it is a common name. It is not a IUPAC name. Next, go for 3-carbon carboxylic acid. This is called propionic acid. Propionic acid. Propionic acid generally known as first fat in body. First fat in body is nothing but propia. That propia indicates propionic acid. So first fat newly generated baby, that is derived the name propio. So that propio is going to be added here. That's why it is called propionic acid. Okay. And if I take 4 carbon acid, CH3 CH2, and here one more CH2, C double bond OH. This is called butyric acid. Butyric acid. So this is commonly derived from butter. So in butter there is a presence of a common acid that is called butyric acid. So that is butter, and this is called butyric acid, also called butanoic acid. That is IUPAC name. Okay, and this is one of the most famous synthetic organic compound prepared in laboratory. This is called urea, but it is derived from human urine. That's why name given as a urea. And one more, if I take a carboxylic acid, alpha position, alpha hydroxy carboxylic acid is called malic acid. This is called malic acid, derived from malus fruits. Malus fruits, best example is apple. That's why it is given as malic acid. Okay, so mostly it is present in apple. That's why it is given as a malus fruits. So malus fruits common source. That's why it is given as malic acid. And one more acid is there, a tricarboxylic acid, that is called citric acid. CH2 CH2, and this is COOH, and here one more COOH. This is called citric acid. So mostly present in citrus fruits. It is present in citrus fruits. Okay, so citric acid derived from citrus fruits. Okay, so that's why the name given as a citric acid, but this is a common name. So lemon, orange are one of the sources for citrus. Okay, so the common acid present in citrus fruits is citric acid. That's why the name given as a citric acid for this molecule. And this is the malic acid. If I put a double bond between these two carbon, that is called also malic acid, but here you see LIEC you will write. But this is belongs to malus fruits, alpha hydroxy succinic acid. With respect to this alpha, beta. So alpha hydroxy succinic acid, also called malic acid. It is present in malus fruits. That's why the common name or the source name is malus. That's why given as malic acid. So these are the few examples for writing a common name of a molecule. Remember, you need to remember some selective molecular common names. That is most important, because some molecule common names also they are asking in variable examinations, especially even for NEET and IIT examination. Most commonly they are asking in NEET examination. Only name related questions are more familiar. So don't neglect common names. Some molecular common names you need to remember. Maybe a source name, maybe a belongs to complete previous, or it may be a source of complete trivial combinations. Okay, so very important thing is, suppose if you want to write any common name of any molecule, that may be repeated. Remember, one common name maybe belongs to more than one molecule also possible. Sometimes some molecules are there, that molecules may not have common name. Maybe they are derived completely in laboratory. That's why there is no specific common names exhibited for that molecule. Okay, so that is about common names. Next. Now we are going to start what is IUPAC nomenclature or IUPAC names. What is nomenclature? Generally nomenclature nothing but giving name of a organic compound. Organic compounds are named in two ways, common in IUPAC. Common names nothing but previous history belongs to that particular compound, source name, etc. Now go through IUPAC name. IUPAC name based on the rules we are giving. Okay, so IUPAC names generally they are belongs to systematic names. IUPAC names are systematic names. Okay, so IUPAC names are generally, it is introduced in 1892 and it is completely established in 1919. In 1919 this committee is establishes. International Union Pure and Applied Chemistry is nothing but IUPAC. So this committee establishes in 1892, introduced in 1892, but finally established in 1918. So what is the use and what is the importance of IUPAC? So generally see, according to vital force theory, organic compounds can't be prepared in laboratory, but once Euler is saying that possible to prepare in laboratory. Later on, new organic compounds are start deriving in laboratory. So in order to give name of an organic compound clearly without repeating one over other, so they are following a systematic nomenclature, nothing but IUPAC. It is introduced in 1892 but completely established in 1918. So it is there in Geneva, Switzerland. Okay, so they are called systematic names. Generally you should say IUPAC. This is the clear way of representing nomenclature of IUPAC molecule. Don't say IUPAC, say only IUPAC. That is the terminology which we need to follow. So it is there in Geneva, Switzerland, introduced in 1892, completely established in 1919, and this is there in Geneva, Switzerland. It is known as IUPAC. And see, every single molecule, if I take a single molecule, so every single molecule have its own name, have its own IUPAC name. Every single molecule have its own IUPAC name. That name cannot be repeated for more than one molecule. There are also systematic names. We are following some generalized rules. It is known as IUPAC. Generally, you will say IUPAC, but this is IUPAC. Every single molecule have its own IUPAC name. Okay, so they are mixture of 5 words. Remember, if you want to give IUPAC name, it is mixture of initially 3, but later on it is split into 5 words. So generally this is called prefix, and here it is root word, and this is belongs to suffix. Prefix, root word and suffix. Prefix is further classified into 2 types. This is a primary prefix, and this is secondary prefix. And here also same. Suffix also further classified into 2 types. That is a primary suffix, and this is called secondary suffix. So prefix is 2 types, suffix is 2 types. Total 5 words will be there. So you remember, if you want to write a IUPAC nomenclature of any molecule, we need to write 5 things. You need to check primary prefix, secondary prefix, root word, then go through primary suffix and secondary suffix. So mixture of these 5 belongs to IUPAC name of any unknown organic molecule. So if you know these 5 clearly, you can fix a name for any organic molecule which is not going to be repeated for other organic molecule. Okay, so you remember this classification and just revise once. IUPAC nomenclature, it's a modified version of giving names of a organic molecule without any confusion. They are called systematic names. Every molecule having its own IUPAC name. IUPAC name cannot be repeated for one molecule to other molecule. That is the first condition. And we are giving names according to the rules. That rules I will explain later. But it is introduced in 1892, 1919 at Geneva, Switzerland. These names are important. And see how to terminology. International Union Pure and Applied Chemistry. So generally don't say IUPAC, say IUPAC. So IUPAC nomenclature generally mixture of 5 words. Primary prefix, secondary prefix, root word, primary suffix and secondary suffix. Next. So we are going to discuss individual rules for an organic molecule. Before that we should know what is primary prefix, secondary prefix, etc. Okay. So first I will explain primary prefix. So represented as PP. What is primary prefix? How it is helpful? Primary prefix, it tells about presence of cyclic ring. Primary prefix tells about presence of cyclic ring. Suppose if molecule having cyclic ring, then we need to use the word cyclo. Cyclo as a primary prefix. You remember this? Try to use cyclo word as a primary prefix if there is a presence of cyclic ring. Suppose if there is no cyclic ring, simply ignore primary prefix. Okay. Suppose I am taking one example. See, there is a 3-membered ring is present. This is a 3-membered ring. Here what I am saying, cyclo 3 carbons are present, propane. cyclopropane. Here cyclo indicates that primary prefix. Now if I take this one, this is called cyclobutane. I am writing cyclobutane. Here cyclo indicates primary prefix of this ring. Okay. Then I can take a 5-membered ring like this. This is cyclopentane. Every time if I use the word cyclo, that is a primary prefix. If there is no cyclic ring, if it is any open chain is present, don't apply primary prefix. Even you can take this molecule for saturate, cyclohexane, ANE I am writing. And see, if I write a conjugate molecule, unconjugate molecule with 1 double bond or 2 double bonds. So see this, here I am using cyclohexene. Hexene I am using, but here I am using cyclo common. So the cyclo indicates that primary prefix. Now if I write 2 double bonds over here, okay, so this is generally cyclo, here I am writing hexa, and if I write position of double bonds 1, 2, 3, 4, first position, fourth position carry double bond, so I can say cyclohexa 1, 4 diene, like that. So a common word which is used over here is cyclo. See, everywhere cyclo is there. So using cyclo indicates that there is a presence of primary prefix. That is the first thing which we need to learn in a IPAC rules. Okay. So by following that 5 rules, we can write IPAC nomenclature. First rule is primary prefix. Generalized rules are different. Following generalized rules, that is different, but this rules belongs to mixture of 5 words indicates that IPAC. Primary prefix indicates presence of ring. Okay. Next, go through secondary prefix. Secondary prefix, it is represented by SP. SP indicates that secondary prefix. Right. What is secondary prefix? How it is helpful? Secondary prefix nothing but generally if any organic molecule having any substitution, second grade functional group after selection of a parent chain, that all are belongs to secondary prefix. So this particular term you can identify clearly while taking examples. Right now you need to remember the names of that particular fragments, what I will write here. Okay. So generally this is applicable after selection of a parent chain. The groups attaches to parent chain or belongs to secondary prefix, otherwise they are also called substitutions. Okay. So we can write like this. Substitutions are locants. Substitutions are locants present on a parent chain. Substitutions or locants present on a parent chain is called secondary prefix. Okay. Secondary prefix is also called second grade functional group. Second grade functional group. It is not a primary functional group, second grade functional group. Second grade functional group is also called substitution. So now I am going to maintain 2 columns. First I will write the fragment or substitution. Second I will write the secondary prefix of that corresponding substitution. Okay. So here it is a substitution or locant and this is called secondary prefix of that particular substitution. Suppose if I write CS3, this bond indicates that it is attaches to parent chain. Now when CS3 is present, try to remember, write methyl. And if I write CS2, CS3, this is called ethyl. If I write CH, one more CS3 and here one more CS3, 2 CS3s are present. You write better here. CH, CS3 and here one more CS3 I am writing. This is called isopropyl. Isopropyl, this is also represented IPR like this. This is represented by ME. It is represented by ET. You need to try to remember even that short forms also. Now carbon attaches to 3 methyl groups. This is neobutyl, also called tertiary butyl. Neobutyl or tertiary butyl. Neo or tertiary butyl. Next, Suppose if carbon having CH2 like this, this is called methylene. Methylene. Especially in cyclopropane, 2 single bonds are present. That 2 single bonds are belongs to sigma bonds. Methylene. Suppose if CH2 is present in the form of double bond, this is called methylidene. This is methylidene. In, end with in. Okay. Suppose if carbon-carbon triple bond is present, this is methylidine. Methylidine. Remember, these bonds indicates that they are attached to parent chain. This double bond indicates it is attached to parent chain. See, if I am not writing any substitution over here, which indicates that this is a substitution attaches to parent chain. Here substitution attaches to parent chain, and this is attaches to parent chain like that. First you need to remember this names. Slowly you will adopt a simple logic to identify parent chain as well as substitution chain. Even substitution chain also belongs to branched chain. So you will understand slowly, but first you follow what actually terms indicates. Next. See, if I write carbon-carbon double bond, here now double bond is outside. Now this is called ethylidene. Ethylidene. If carbon-carbon triple bond is present, this is called ethylidine. Ethylidine. Okay. Suppose if isopropyl group is present outside, see, CH2 double bond is outside. This is called isopropylidine. Isopropylidine. Okay. Then see, carbon-carbon double bond is present, and this carbon attaches to CH3 and this one. So this is called isopropynyl. Isopropynyl. Enyl we can use. Isopropynyl. Suppose carbon-carbon double bond is present. This is called vinyl. It is comes from ethene. This is called vinyl. Also called ethynyl. Vinyl or ethynyl. This substitution attaches to parent chain. Remember, it is a substitution attaches to parent chain. This bond indicates that it is attaches to parent chain. Remember, this is always attaches to parent chain like this. 3 bonds attaches to at a time to parent chain. Here also 2 bonds attaches to parent chain. Right? Now, see, if carbon-carbon triple bond is present, this is called ethanyl. Triple bond is ethanyl. Right? Then, if any double bond is present over here, see, this is, generally you try to give numbering from here. Parent chain adjacent carbon is 1, 2, 3. So this is called second position double bond is present 2 propynyl. I am saying 2 propynyl. Why I written 2? Because second position there is a double bond is present. That's why it is called 2 propynyl. Now if I write a triple bond or same double bond at first carbon, CH3, and yet this carbon-carbon double bond is present. So if I start numbering 1, 2, 3, this is 3. So I can say 1 propynyl. Like that, if any chain is present, end with IL. Remove letter E here. Propene. If I say propene, remove E, write down YL. Okay, that is this case. Now, suppose if any X is present, X nothing but any halogen. Fluorine, chlorine, bromine, iodine. So just say halo. Chloro, bromo, like that. Suppose if any rings are present, 3-membered ring is there. Cyclopropyl, and if 4-membered ring is there, cyclobutyl, and you can also write 5-membered, cyclopentyl, cyclohexyl, etc. You can use this cyclo word with corresponding number of carbons over here. Cyclo is indicates that ring, propyl indicates that 3-carbon ring. So the 3-carbon ring attaches to parent chain. That is the meaning. So you can use even 5-membered, 6-membered, etc. Okay. Next, see, if there is a presence of OH group, this is, you can end with hydroxy. If there is SH is there, sulfonyl, and if there is a presence of OR, This is called alkoxy, secondary prefix, OR, methoxy, ethoxy, isopropoxy, like that. Okay. Then there is a presence of CHO. CHO nothing but generally belongs to aldehyde. It is also called formyl. Formyl, also called aldo. Sometimes it is also ended with oxo. Use this as oxo. Now, if any C double bond O group is present, this is called keto. Keto also called oxo. Keto, oxo, we can use any. Now, suppose if I use COOH in place of this, I am using C double bond OH. So I can use hydroxycarbonyl. Hydroxycarbonyl. If I use halogen, acid halides, halocarbonyl. Halocarbonyl, simple. If I use any ester group over here, C double bond OR. So I can say alkoxycarbonyl. Alkoxycarbonyl. Then I can use C double bond O like this. This is called acetoxy. Acetoxy, otherwise acetyl oxy. Acetoxy or acetyl oxy. Anhydride. Generally, anhydride is given name for principal group. Now, this is called acetoxy. Okay. So, C double bond O NH is present. This is called carbamyl. Carbamyl. If I write one alkyl group here, primary carbamyl, alkyl carbamyl, dialkyl carbamyl. If these two hydrogens replaced by two alkyl groups. So some selective groups are present like CN. CN nothing but cyano. I can also use NC. NC is nothing but isocyano. Okay. Then I can use NO2. NO2 nothing but nitro. Okay. Then if I write NO, NO nothing but nitroso. Nitroso. Next, if I use benzene attaches to any group, this is phenyl. Phenyl, otherwise say aryl. Phenyl or aryl. Suppose if it is attaches to CH2, this is called benzyl. This part. This is attaches to parent chain and this part is called benzyl. Then if I replace these two with two substitutions, this is called benzol. Benzol. If this carbon having only one hydrogen, benzol. And if they carry only no hydrogen, this is called benzo. Benzo. Suppose if that carbon attaches to oxygen, this is attaches to oxygen, it is further connected. So this is called benzyl oxy. Benzyl oxy. Like that we can use many names. So the most common names I am giving, which is repeating in your examination. So this is halogen attaches to carbonyl. So when halogen attaches to carbonyl, generally it should be represented as haloformyl. Suppose if I write hydrogen, that is called formaldehyde. So I can say bromo formyl. This is about secondary prefix. Bromoformyl, you can use chloroformyl, fluoroformyl. Use any kind of halogen here. If it is attaches to C double bond O group, that is belongs to formyl group. Okay, so that is about secondary prefix. Next is third one, root word. So root word tells about presence of number of atoms in a longest parent chain. How many number of atoms present in a longest parent chain is nothing but a root word. Otherwise you can say number of carbons present in a given parent chain. Okay. So root word tells about presence of number of carbons in a parent chain. how many carbons are present in a parent chain? Explained by root word. Suppose if one carbon is present, this is well known, meth. 2 is there, eth. 3 prop, but. 5 carbons are present, pent. Not only carbons, other elements even. If 6 carbons are present, hex. 7 hept. If 8 carbons are present, oct. Non. So 10 carbons, dec. 10 carbons, dec. If 11 carbons are present, undec. 12 carbons, dodec. If 13 carbons are present, tridec. Like that it is keep on progressing. Tetradec, pentadec, hexa, octa, nonadec, and completely if you get 20, so this is ecos. C21. Hen ecos. Henicos. So C22. Di ecos. Like that. Triecos, tetraecos, pentaecos, nonaecos. Finally you will get 30. So this is called triaccount. Triaccount, C30. 31. Uni triaccount. Uni triaccount. 31. 32. Di triaccount. Like that. Suppose if C40 carbons are present, tetraaccount. C50 pentaaccount. Pentaaccount. C60. C60 many names are there. First one it is hexaaccount. Hexaaccount, also called Buckminster Fullerene. It is called Buckminster Fullerene, also called buckyball, soccer ball, etc. Many names are there. C60 is very, very important. C60, hexaaccount, also called buckyball, soccer ball. Okay, so Buckminster Fullerene, like that. So C70, heptaaccount. Like that we can write 80, 90, octaaccount, nonaccount, then finally C100. This is called hectane. If it is alkane, ane, hectane. 200. So this is dihect. Dihect. Hectane, dihectane. If I write ane, it is alkane, remember. Dihect. Okay, so like that. Trihect, tetrahect, nonahect. Nonahect is nothing but 900. Pentahect nothing but 500. Then finally I can write 1000. 1000 nothing but kili. 2000. So from here onwards it is changes. Daily. Li what will come? 300. Trili. 400. Pentali. 500. That is 5000. 500 nothing but pentahect. 1000 nothing but kili. 2000 nothing but daily. Okay, so if I take 3000, this is trili. 5000, from here to here 5000, pentali. And if I take 9000 carbons if they present, or 9000 atoms are present, this is called nonali, like that. So these are general root words for a given skeleton having 9000 or more than 9000 up to 10,000, below 10,000, 9999. How many set of carbons are present or set of atoms are present in a parent chain, that is expressed in terms of root word. So just revise once. Root word. Remember, root word indicates that how many number of carbons or atoms present in a longest parent chain. So up to you people, well known about around 20 up to, maximum 20, but I given up to more than 1000. But you need to be familiar up to 30. So up to 9 carbon are well known. Meth, eth, bute, pent, hex, oct, non, then finally decane. Level is undec, duodec, tridec, ecosane. 20 is ecos, 21 is enicos, doicos or diicos. Triaccount. From here onwards you will get account. Triaccount, tetraaccount, pentaaccount, hexa, hepta, octa, like that. Finally, C60 is very, very important. C60 nothing but hexaaccount. Hexaaccount, also called Buckminster fullerene. This is also called soccer ball, buckyball, many names are there. C70 nothing but heptaaccount. So like that, if you continue up to 100, 100 nothing but hectane. 200 dihect. 1000 is kili. 2000 daily, trili, pentali, up to 9000. 9000 is called nonali. Here every time this word end with li. So that is about root word. Next, fourth one in this case. First primary prefix, secondary prefix, third one is root word. Now fourth one is primary suffix. What is primary suffix? How it is going to be helpful? So primary suffix tells about whether given skeleton is a saturated or unsaturated. It may be a saturated or unsaturated, that is explained by primary suffix. Saturated nothing but single bond, unsaturated nothing but double bond or triple bond. Suppose if it is saturated carbon-carbon single bond, what is the secondary prefix used here? AN. If carbon-carbon double bond is present, use EN. If carbon-carbon triple bond is present, use IN. So these are the saturate, this is saturate, and these two are unsaturated. This is saturate AN. If it is a unsaturated EN, unsaturated triple bond YN. So that is about primary suffix. Okay. Then it is very, very important one. Secondary suffix. Secondary suffix. What is secondary suffix? How it is going to be helpful? This is one of the dominating rule out of that 5. So why I am saying it is a dominating rule out of 5? Because especially secondary suffix will decide which is a parent chain and which is a substitution chain or substitution or branched chain. Okay. So secondary suffix which will tells about presence of parent chain or parent functional group. It tells about parent functional group. Otherwise I can say simply parent nuclei. Otherwise you can say riding group, also called principal chain, otherwise principal group or principal functional group. Means it is a starting point for giving a nomenclature or giving a numbering. So presence of parent functional group or riding group or principal group is nothing but secondary suffix. And if you know the secondary suffix clearly how to write, then it will be very easy to write secondary prefix to identify, I am saying. Okay. So now I am writing 2 columns, just concentrate. So here I am writing functional group. Here I am writing functional group, and here I am writing secondary suffix. Functional group and secondary suffix. 2 columns I am maintaining. So try to remember this, how to write. So first I am writing very, very important one, hydrocarbon. So what is the meaning of hydrocarbon? Hydrocarbons. Hydrocarbons generally you can write a single bond, alkane, double bond, alkene, then go for alkyne, then all types of rings, cycloalkane, alkadiene, like that we can use any one. any hydrocarbon if I take, remember if it is any hydrocarbon, which means the skeleton or the functional group which carry only carbon and hydrogen, that is called hydrocarbon. If molecule carry carbon and hydrogen only, then on that time I can end with name, that is E. That molecule end with E. If it is alkane, single bond, E, end with E. See, just check out. Methane, ethane, propane. If it is a double bond, also end with ene. Triple bond also end with ene. Simple ring, double bonded ring, triple bonded ring, alkadiene, any hydrocarbon. It may be even benzene also. Any hydrocarbon means skeleton carry only carbon, hydrogen, but not any other element. That is called hydrocarbon. If it is hydrocarbon, end with E. Okay, then suppose if it is OH, end with OL, it is SH, this is thiol or mercaptans. Suppose if it is C double bond OH, this is AL, methanol, ethanol, like that, formaldehyde. So this is ketone end with ONE. Suppose if it is carboxylic acid, end with oic acid. You remember this secondary prefixes. Alcohol, thiol, formaldehyde, ketone, carboxylic acid, oic acid. Suppose if it is C double bond OR, this is O8. Ester is end with O8. Methyl methanoate, ethyl ethanoate, like that. O8. Now if I write C double bond O X, this is end with OYL halide, methynyl chloride, like that. This is O8, OATE, O8, OYL halide, methynyl chloride, ethynyl chloride, etc. Okay, then if I write C double bond O like this, this is N-hydride. Suppose if I write C double bond O double bond N, this is called nitrile. Cyanide, IPAC name generally represents nitrile. Okay, if I write NC, don't say isocyanate, this is called carbylamine. And if I take NH2, so before that you take C double bond O NH2. This is called amide, organic amide it is, C double bond O NH2. Primary amide, if I write one more alkyl, secondary amide, two alkyl, tertiary amide. Used in Hoffman rearrangement. Remember, this is called amide. Acid, ester, acid halide, amide, anhydride, cyanide, isocyanate, this all are belongs to acid derivatives. Then if I write NH2, this is called amine. Primary, secondary, tertiary amines, all are functional isomers. Okay, so then if I write SO3H, sulfonic acid, and if I write NO2, nitroalkane. If it is alkane, nitroalkane, but generally nitroalkane, anything is possible. Nitro, next where it is attaches, either double bond, single bond or triple bond, nitroalkane. Then if I write NO, ONO, so I can write alkyl nitrite. Okay, so these are the few selective secondary suffixes for relative functional groups. You need to remember this. There is no other alternative. Only practice will show more evidence for remembering this particular molecules. Only practice is required. Keep on practicing one molecule to other molecule. Then you people will aware about this all molecules clearly. Okay. Yes. See this. That is about the rules. See this all. So now I'm going to revise all at one place so that 5 rules I want to apply at a time. Just make a short revision. IUPAC nomenclature. Generally, if you want to give name of any organic molecule, it is possible with 2 ways. Only 2 ways you can give. First one is common name. Second one is IUPAC name. This is common name and IUPAC name. What is actually common name indicates and what is IUPAC name indicates? Common name nothing but previous history of that molecule or source name, also called trivial. Trivial nothing but previous. From where it is extracted, where it is derived, what is the previous history of that molecule. Based on the corresponding sources, these names are given. They are not follow any rule, that's why they are called non-systematic rules. There is no limitations for this. One common name maybe belongs to 2 or 3 molecules even possible. Sometimes molecule may not have common name. Best example, formic acid comes from red ants. Then go for some selective for common names are given. Acetic acid, acetum, propionic acid, first fat in body, deuterium butter, urea, urine, malic acid, citric acid, different fruits and urine extraction is observed. Okay, IUPAC name. What is IUPAC name? Generally, IUPAC names nothing but systematic names. By following generalized rules, if you give name of any organic molecule, that is called IUPAC name. Introduced in 1892, established in 1919. Clearly given from 1919. Why IUPAC, International Union Pure and Applied Chemistry, is required? Because after introducing many synthetic organic compounds in laboratory, so they are planning to give a systematic rules to give a molecule clearly. So that's why they are establishes one committee in Geneva and Switzerland. It is given as IUPAC. Every organic molecule have its own name, also called single molecule have its own name. IUPAC is mixture of 5 words: prefix, root word, suffix, primary prefix, primary secondary prefix, root word, primary suffix, secondary suffix, etc. What is primary prefix indicates? Primary prefix, presence of rings, use cyclo. Secondary prefix, all are substitutions. Just remember the names of the substitutions. All substitution names are given. Okay. So if you remember these names, then only you can apply very easily. Then go through root word. Many names are given. How to use root word up to 9,999 are given. Just go through it. Then go for primary suffix, indicates presence of single bond, double bond and triple bond. Then at last what is secondary suffix, which indicates that how to use a functional groups. E like that. All hydrocarbons C, alcohol OL, thiol, aldehyde Al, ketone one, acid oic acid, ester O8 acid halide, OAl halide, etc. So you need to remember this all secondary suffixes for individual functional group. So then you will get a clarity in case of secondary suffix and secondary prefix clearly. Over. Next. Just see few examples I will show how to apply these 5 rules at one place to give a correct name. First example I am showing now. See, this is well-known example. Now 5 things is required: primary prefix, secondary prefix, root word, primary suffix, secondary suffix. See, is there any presence of ring here? No. That's why cancel it. Any substitution? No substitution. Root word. What is root word? 2 carbons are there. Eth. Carbon-carbon single bond. An. And it is only hydrocarbon, that is E. Root word is 2 carbon. Primary suffix, single bond is present, An. Secondary suffix, it is hydrocarbon. Hydrocarbon end with E. That's why complete name is ethane. Same way if I write carbon-carbon double bond, there is no primary prefix, secondary prefix here. Root word is directly eth. Only eth. Carbon-carbon double bond E. Hydrocarbon it is ene. So I can say ethene. Okay. Carbon-carbon triple bond. Now there is no ring, no primary prefix, no substitution. Root word is what? Eth. Secondary prefix triple bond An. Sorry, Yn. Triple bond is there Yn. It is hydrocarbon, that's why end with E. Name is ethyne. Okay. So suppose if I take any ring, see, primary prefix, secondary prefix, root word, primary suffix, secondary suffix. If I consider this example, so primary prefix, there is a presence of cyclic ring, use cyclo. There is no substitution, no secondary prefix. Root word is hex, double bond is present. Root word is hex, 6 carbons are present. Primary suffix, double bond is present, En, and it is hydrocarbon. So this is known as cyclohexene. Like that, name will come automatically. No need to add any letter, no need to remove any letter. By joining this all, you will get one name, that is IUPAC name. Okay, so if I take this one selective functional groups I am using. Now, primary prefix, secondary prefix, root word, primary suffix, secondary suffix. There is no ring, no substitution, root word. Root word is eth, 2 carbons are there, eth. Then there is a presence of carbon-carbon double bond, single bond or triple bond. Primary suffix tells about presence of double bond, single bond and triple bond. Primary suffix tells only single bond. So I can say AN. Secondary suffix for OH is OL, alcohol. Secondary suffix is OL, not hydroxy. OL. So name is belongs to ethanol, like that. Name will come like this. Suppose if I give this one, C double bond OH. No primary prefix. In this there is no ring, no substitution. Root word is prop. 3 carbons are present. I can write prop. Then after prop, between carbon-carbon there is no double bond. See, no need to see the double bond between carbon and other heteroatoms. Try to see only double bond or triple bond or single bond present between carbons only. Here between carbon, single bond. Out of this all connectivities, only single bonds are present between carbon, not between oxygen and carbon. So between carbon there is a single bond is present, so I can end with AN, and this is aldehyde, Al. So I can say propanal, Al nothing but aldehyde. Okay. Then last example. See, similarly I can use 4 carbon acid. This is 4 carbon consisting acid. Primary prefix is absent. Secondary prefix is also absent in this one because there is no substitution. There is no ring. These two are absent. Then root word 1, 2, 3, 4. So this is called but. Now, primary suffix tells about whether between carbon, single bond, double bond, triple bond is present or not. Only between carbon-carbon we need to see. Between carbon-carbon all are single bonds are present. So I can use AN. Then there is a presence of carboxylic acid. Okay, so this is end with oic acid, right? So carboxylic acid, what is the secondary prefix for carboxylic acid? Oic acid. Oic acid. So I can say directly, complete name is butanoic acid. That is secondary suffix usage as a riding functional group as compared to substitution. Okay, so that is introduction part of nomenclature. Hope you people understood. So if you want to apply nomenclature for every individual functional group, first you need to know these 5 rules. How to apply this? Just now I explained with few examples. Try to apply for all. You will get names very easily if there is no proper substitution. So in your next class you will see how to use nomenclature by using a generalized rules. Okay, then I will explain individual functional groups with substitution, with multiple substitution, with bicycles, spiros, whatnot. Everything will be covered in this particular concept of nomenclature. So don't miss second class. First I will explain the three rules get classified into 5. Later on, IUPAC rules for giving name clearly by substitution or by multiple identical substitution, non-identical substitution, bridges, etc. That is generalized rules are there. That generalized rules you will understand in your second class. Okay, so thank you for watching. Thank you for subscribing our channel, and try to suggest your friends. We are giving this free NEET classes, and that will be helpful for your upcoming examination. Okay, practice this. See you in next class.